There's a lot of talk about space weather, solar flares, CMS, but what do these terms actually mean? How does the sun affect the Earth, and why should we care? I'm an award-winning science journalist with a degree in astrophysics. I make videos about the amazing science that happens all around us, including space weather. This series is designed to be a fun and easy introduction to the basics of space weather. It's like a 101 course that everyone from solar physicists to high school students to anyone who is just curious can take together. We'll start off with some basics, and by the end of this series, you lines know what exactly happens when the solar wind hits our planet and how scientists measure and predict these events. We're going to take a Neil deGrasse Tyson approach here. So get ready for some fun analogies and some great stories about the people behind the science. And I'm sure you'll learn a thing or two while being entertained. So let's start with the sun. Our lives are totally dependent on it. Plants use its energy to grow, which we then eat. Its gravity holds the planets in their orbits. And if you live in the northern hemisphere, you probably know that it is also responsible for those beautiful summer nights with the sky full of fireflies and the air full of warmth. But the sun can also be dangerous. It occasionally throws massive tantrums, sending plasma and radiation hurling through the vast emptiness of space towards Earth at 186,000 miles per second. Let's unpack this a little. What is plasma? Just like water vapor is water in gas form, plasma is just matter in an ionized gas form, meaning that some or all of the atoms have lost one or more electrons, which makes them electrically charged. The sun's plasma is mostly made up of hydrogen and helium. Now remember that all that stuff you learned about electric charges in school, like how opposite charges attract and similar charges repel. Well, that comes into play here because the solar wind consists of electrically charged particles. So as it streams away from the sun, it interacts with the magnetic fields of the planets just like a stream of tiny charged marbles would interact with a giant magnet. Now back to our solar tantrums. They come in many shapes and sizes, but the most violent ones are called solar flares and coronal mass ejections. We'll talk about these in detail later. For now, just remember that they are big bursts of plasma and radiation that can seriously mess with life on Earth. But luckily, Earth has a powerful magnetic field that acts like a force field, deflecting most of the plasma and radiation back into space. However, some of it does penetrate our field, and when it hits our atmosphere, it can cause all sorts of chaos. It can disrupt important things like our telecommunications and our power grid system. And it even messes with our GPS. And finally, the last thing we want is for people to think that space weather is fake news or that climate change is a hoax. Understanding how our world really works helps us appreciate just how delicately balanced our modern society is. We're so dependent on things like the internet and satellites that it only takes a small nudge to send ripples across the globe. So if you stick with me through this series, you learn how we keep tabs on the sun and get warnings when it is about to throw one of its plasma tantrums. You understand why astronauts are at risk of radiation poisoning and how satellites can get fried by a solar flare. By the end of this series, you know what exactly happens when the solar wind hits our planet and how scientists measure and predict these events. This series is brought to you with the support of a national lab. Their mission is to understand the fundamental physics of space, weather, and the Sun-Earth connection to protect our increasingly technological society from the ever-present threat to our modern way of life from space weather. When we think of the sun, we often picture a giant ball of burning wood or maybe a gigantic nuclear reactor. But the truth is that the sun is not hot. Only the surface is about 10,000 degrees Fahrenheit, which is hot, but not nearly as hot as the core of the sun. There, the temperature reaches a staggering 27 million degrees Fahrenheit. That's 15 million degrees hotter than the surface of a star like the sun. So why isn't the surface as hot as the core? Well, that's because the core is under tremendous pressure, which makes it hot. But the surface isn't under as much pressure, so it's relatively cool. Okay, class dismissed. Do you still have questions? Leave them in the comments below.